Good morning children. This class will discuss about quantum numbers, what are the different types of quantum numbers and what are the three rules are useful in forming the orbital diagram followed by electronic configuration. These things we are going to discuss today, right? So first let me move to the quantum numbers. What are called quantum numbers? So quantum numbers means the set of four integers required to define an electron completely in an atom are called quantum numbers. Okay. So a total of four quantum numbers are required to define an electron completely in an atom are called the quantum numbers. Okay. So important 2 mark question. What are called quantum numbers? A set of four integers are required to define an electron completely in an atom are called the quantum numbers. Okay. So total of four quantum numbers are required to define an electron completely in an atom are called quantum numbers. Right. There are four types of quantum numbers. First three only is given in your book, but when you come to higher classes, you will learn about the fourth quantum number. Right. So what are the three quantum numbers? First one is the principal quantum number. Second one is azimuthal quantum number. Third one is the magnetic quantum number. Okay. Now we will discuss about these three types of quantum numbers. First one is the principal quantum number. So principal quantum number describes the size of the electron wave. Okay. So principal quantum number, it is represented by the letter N. Principal quantum number, it is represented by the letter N. So this quantum number, it describes the size of the electron wave. So this is very important in principal quantum number. Principal quantum number describes the size of the electron wave and the total energy of the electron. Okay, not only the size of the electron wave, also it describes the total energy of the electron. Okay, and this principal quantum number, it has the integral values starting from 1, 2, 3, 4, etc. Okay, so principal quantum number is represented by the letter N. It describes the size of the electron wave and the total energy of the electron. Its integral values are 1, 2, 3, 4. Right? Next, the maximum number of electrons that can be accommodated in each energy shell is given by 2n square. This point also important in principal quantum number. Okay. So first quantum number is principal quantum number. It is represented by the letter N, small n, and principal quantum number describes the size of the electron wave and also it describes the total energy of the electron. Okay, it has integral values. This principal quantum number has integral values from 1, 2, 3, 4, etc. And the maximum number of electrons that can be given in each maximum number of electrons which can be accommodated in each energy shell is equal to 2n square. Right? Next one is azimuthal quantum number. Azimuthal quantum number is represented by the letter L, small l. Okay. So, azimuthal quantum number, it describes the shape of the electron cloud. Okay, what we saw in first one principal quantum number, it describes the size of the electron wave. But in azimuthal quantum number, it describes the shape of electron cloud and the number of subshells in a shell. Okay, the number of subshells in a shell. Azimuthal quantum number describes the shape of electron cloud and the number of subshells in a shell. It has also values from 0 to n minus 1. This is the value we have to use for calculating the azimuthal quantum number. Okay. So next one is the magnetic quantum number. It is represented by the letter small m. Okay. Okay, so magnetic quantum number describes the orientations of the subshell. Orientation means it is nothing but the position. Okay, so magnetic quantum number describes the position of the subshells and its values ranging from -1 to +1 including 0. Okay, so this is magnetic quantum number. First you have to explain the, you have to mention the, it is represented by the letter. Next you have to mention each quantum number describes some specified thing, isn't it? That you have to mention. Next you have to mention its integral values. Okay, so three quantum numbers are principal quantum number, magnetic quantum number, another one is azimuthal quantum number. The fourth quantum number is the spin quantum number and it is represented by the letter small s. Okay, spin quantum number describes the angular momentum of an electron and it has the values from +1/2 to -1/2, but when you come to higher classes you will learn about the spin quantum number. Now you learn these three quantum numbers only because these three quantum numbers only it is given in your book, right? So what's the first quantum number? First one is the principal quantum number, second one azimuthal quantum number, third one is the magnetic quantum number. Got it? So quantum number means what? Quantum number means a set of 4 integers. Okay, otherwise a total of 4 quantum numbers are required to define an electron completely in an atom are called the quantum numbers. Got it? Right. Next we can move to 3 important principles. Okay, 3 principles are required to mention the orbital diagrams. Okay, what are the 3 principles? The first one is the half-bar principle. Okay, first one is half-bar principle. Actually, this word half-bar is derived from the German word. Okay, the meaning for half-bar is to build up or to construction. So this half-bar is a German word and its the meaning for half-bar is to build up. Okay, so the half-bar principle was formulated by the famous scientist Niels Bohr. Okay, so according to this half-bar principle, the subshell with minimum energy is filled up first, and when this subshell obtains maximum number of electrons, then the next subshell with higher energy starts filling. This is half-bar principle. Okay, so half-bar principle states that each electron occupies the lowest energy orbital. This is the one-line concept of half-bar principle. Okay, so half-bar principle states the subshell with minimum energy is filled up first, and when the subshell obtains maximum number of electrons, then the next subshell with higher energy starts filling. Okay, each electron occupies the lowest energy orbital. This is the concept behind the half-bar principle. Half-bar is a German word and the meaning for half-bar is to build up or construction. This half-bar principle was formulated by Niels Bohr. Okay, right. Second one, Pauli exclusion principle. Pauli exclusion principle was formulated by the Austrian physicist Pauli. Okay, physicist means those who is well versed in physics, right? So, according to this principle, no 2 electrons in an atom can have the same value of all 4 quantum numbers. Okay, I repeat again. No 2 electron in an atom can have same value of all 4 quantum numbers. Second one, an orbital can accommodate maximum 2 electrons with opposite spin. An orbital can accommodate maximum 2 electrons with opposite spin. Okay, so Pauli exclusion principle states that only two electrons can fit into a single orbital. This is the one-line concept of Pauli exclusion principle. Okay. No two electrons can be occupied in a single orbital. Okay. Only two electrons can occupy in a single orbital. Right. So next one, Hund's rule. Okay. Hund's rule states that electrons are distributed among the orbitals of subshell in such a way as to give maximum number of unpaired electron with parallel spin. Hund's rule was formulated by the famous German physicist Hans. Okay, so he was well known for his work on atoms and molecules. Okay, so according to Hund's rule, electrons are distributed among the orbitals of subshell in such a way as to give maximum number of unpaired electron with parallel spin. Okay, so each electron can go into different orbitals in the same subshell before doubling up inside the orbital. Okay, this is the concept behind the Hund's rule. Okay, so electrons can go into different orbitals in a subshell before doubling up inside the orbital. Right? So this is the Hund's rule. Okay. So next we can move to orbital diagram. Orbital diagrams are the pictorial representation of arrangement of electrons in an atom. Okay, so this is the orbital diagram. In this way, electrons can start filling. Okay, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, like that for 5 years, 6 years, it will go on like that. Okay, so electrons start filling the 1s orbital first, then it starts 2s, then it will move to 2p, 3s, 3d, 4s, like that electrons will start filling. Okay, so orbital diagram or the pictorial representation of arrangement of electrons in an atom. So this is the diagonal rule for electron filling order. This is the diagonal rule for the electron filling order. Okay. So in an orbital diagram, a square represents the orbital. Okay, this square represents the orbital, whereas these arrows indicates the electrons. Okay, the square indicates the orbital, whereas this two electrons, these two arrows will indicate the electrons, and here the upward arrow indicates the electrons spin in one direction, whereas the downward arrow indicates the electrons spin in another direction. Okay, right. So next we can move to electronic configuration. Chemists use electronic configuration to describe the arrangement of electrons in an atom. So what is meant by electronic configuration? The arrangement of electrons in various shells of an atom of the element is known as the electronic configuration, right? If we know the atomic number of the element, then we can easily determine the electronic configuration, right? Okay, so while writing electronic configuration, a standardized notation should be followed. Okay, so see this one. Here 1 is what? This one indicates the energy level. S indicates the type of orbital. Okay, S orbital, P orbital, D orbital, F orbitals are there. So this S indicates the type of orbital, and here this 1 indicates the number of electrons present in an atom. Okay, so standardized notation should be followed. This point you have to remember, right? Okay, now we can see some elements based on the arrangement of electrons. Okay, See this one. This is the first one is the hydrogen element. Okay. The atomic number of hydrogen is 1. Okay. So here one electron is present in the first shell. Inside the nucleus, what is present? Protons and neutrons. These are protons and neutrons. The center part is called the nucleus. In the nucleus, protons and neutrons are present, whereas electrons revolve around the nucleus in circular orbit. Okay, so this is the hydrogen element. Next one, this is the boron element. Its atomic number is 5. Okay, so this is the center part. In the first orbit, how many electrons are present? 2 electrons. 1, 2, and in the second orbit, 3 electrons are present. 1, 2, 3. So totally how many electrons are present in boron element? 5 electrons. Okay. So for this boron element, this is the outermost orbit. So what is the balanced shell? Balanced number of boron element? It is 3. Okay, because 3 electrons are present in the outer shell. Got it? Right. So next one is the oxygen element. The atomic number of oxygen is 8, right? So in the first orbit, how many electrons are present? 2 electrons. Okay, 2 electrons are present in the first orbit, and in the second orbit is the outermost orbit for oxygen element. So in the second orbit, 6 electrons are present. 1, 2, 3, 4, 5, 6. So 6 electrons are present. So what is the atomic number of oxygen? Atomic number of oxygen is 8, right? And in the first orbit, 2 electrons are present. In the second orbit, that is outermost orbit, 6 electrons are present. Okay, right. Next, we can move to sodium element. Sodium atomic number is 11. So in the first orbit, 2 electrons are present. In the second orbit, this is the second orbit. How many electrons? 8 electrons are present. Count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. And in the outermost orbit, how many electrons are present? It is 1, right? Okay. Next we can move to carbon element. So atomic number of carbon is 6. So in the first orbit, 2 electrons are present. In the outermost orbit, 4 electrons are present. So 2, 4. Next one, nitrogen element. Okay, nitrogen atomic number is 7. So in the first orbit, 2 electrons. In the outermost orbit, 5 electrons. So 2, 5. Next one, helium element. Helium atomic number is 2. See, in the outermost orbit, only 2 electrons are present. Next one, magnesium element. Its atomic number is 12. So in the first orbit, 2 electrons are present. In the second orbit, 8 electrons, and in the outermost orbit, 2 electrons. Okay, so 2, 8, 2. Next one, sulfur element. This is sulfur element. Its atomic number is 6 plus 2, 8 plus 8, 16. Okay, atomic number is 16 based on this electrons revolve. So, in the first orbit, 2 electrons. In the second orbit, 8 electrons. And in the outermost orbit, 6 electrons. Okay, so 2, 8, 6. Next one is the chlorine element. Atomic number of chlorine is 17. In the first orbit, 2 electrons. Second orbit, 8 electrons, and in the outermost orbit, 7 electrons are present. 1, 2, 3, 4, 5, 6, 7. Okay, so 2, 8, 7. Next one is lithium element. Atomic number is 3. In the first orbit, 2 electrons. Already we saw, isn't it? Maximum 2 electrons can accommodate each energy level. Okay, and in the outermost orbit, 1 electron is present. So 2, 1. Next one is argon element. Atomic number is 18. So in the first orbit, 2 electrons. In the second orbit, 8 electrons. And in the outermost orbit, count 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8, 8. So if you know the atomic number, then we can easily determine the electronic configuration of an element. Okay, electronic configuration means what? The arrangement of electrons in various shells of an atom of the element is known as the electronic configuration. Got it, children? Right. So what are the things we have discussed today? One is about the quantum numbers. What are the different types of quantum numbers? What are the three rules are useful in making the orbital diagram? Finally, we discussed about the electronic configuration. Got it, children? Right. So go through all the contents what we have discussed today. Complete the assignment and send it to WhatsApp group. Thank you, children.